Hello everyone, I'm Avnish Joshi. Our topic is a load balancing algorithm for data centers to optimize cloud computing applications. It is based on the research paper in IEEE Access 2022. It is going to be presented by me, Rahi Joshi and Kunj Gohil. Today we will walk you through our work on load balancing algorithms tailored for data centers in cloud computing environments. We specifically focus on infrastructure as a service where efficient task distribution is crucial to prevent performance degradation. Load balancing here is not just technical optimization, it's a key to better user experience and server reliability. Now coming on to the role of virtualization in infrastructure as a service, virtualization underpins everything. So it allows us to spin multiple VMs on the same physical infrastructure using hypervisors. However, improper VM management can cause delays or overuse. That's where smart scheduling and allocations come in. Coming to the importance of load balancing in cloud environments. So basically load balancing minimizes delays, maximizes VM usage and reduces SLA violations. If a VM is overloaded, tasks may fail or get delayed. Our goal is to ensure a balance, neither underutilized or overburdened VMs. Coming to our problem statement, so the major issue is that the current algorithm don't consider real world parameters like deadlines and task priority or execution constraints. Moreover, many ignore VM overload and SLA violations. This creates a need for a dynamic SLA aware and QoS driven solution. Now, my teammate Rahi will speak.
Hello, my name is Rahi. Now we will move on to research objectives and contributions. Our proposed algorithm is built around dynamic scheduling. It actively checks for SLA compliance and migrates workloads if needed. Notably, we achieved 78% resource utilization in simulation, an indicator of strong efficiency. Now we'll move on to the next slide, which is review of existing algorithms. Let's review where others fell short. Algorithms like FCFS and round robin are simplistic. Min-max algorithm and maximal algorithm ignore SLA deadlines. OLB doesn't even consider execution times. These motivated our approach. Now we move on to the key concepts, which is our strategy uses three parameters: task length, deadline and arrival time. These form the foundation for a smarter scheduling system. Scheduling and load balancing are deeply interlinked. Without good scheduling, load balancing is ineffective. Now we move on to proposed architecture. Our framework has two layers. The top layer handles user requests and assigned deadlines. The bottom layer ensures that the tasks are migrated if a VM risks violating an SLA. This avoids bottlenecks while still respecting the task constraints. Now we move on to SLA-aware load balancing logic. Here, the core logic is that if the task completion time exceeds its deadline, the VM is flagged. We either boost its CPU, share, or migrate its workload. This way, tasks don't just fail, they are rerouted. Now we move on to the pseudocode explanation. Now a brief walkthrough of our logic. We calculate the completion time of each task and compare it to its deadline. If the task risks SLA violation, we configure the resources or migrate it. Now I would like to pass on to my friend Kunj Gohil.
My name is Kunj Gohil. We'll move on to the topic simulation setup. To test this, we use CloudSim on NetBeans with 2 to 6 VMs and 10 to 40 cloudlets. We varied arrival times, task lengths, and deadlines to simulate real-world cloud usage. Moving on to the next slide, which is performance matrix. We measured 3 key metrics: Makespan, which is total finish time; execution time, which is how long each task took; and resource utilization. Higher RU means better CPU usage. Our goal was to keep it close to 1. Moving on to the next slide, experimental results. Here's what we found. Execution time and Makespan scaled predictably with more cloudlets and VMs. Even at the high end 40 cloudlets, our algorithm performed within acceptable ranges. You can see the trend in this graph. Moving on to the next slide, which is resource utilization analysis. We achieved 78% utilization with 6 VMs, a best case. More importantly, the algorithm stayed stable even as we added more load. That's the real test of scalability. Moving on to the next slide, which is comparison with dynamic LBA. Compared to an existing 2017 algorithm, ours had lower Makespan and higher RU. This shows how integrating SLA awareness and dynamic task migration pays off. The last slide, which is conclusion and future scope. To conclude, SLA-aware task scheduling and intelligent migration significantly improve cloud efficiency. In the future, we aim to extend this to hybrid and multi-cloud systems and apply it to real-time applications like video streaming. Thank you.